What's going on? I'm Blaine from AceMine. Today, we are continuing our Code Along series by looking at how we can get NBA player correlations from the NBA API. So we're going to do a little bit of showing you how to use the browser to understand how the NBA API works. And then we're going to kind of cheat a little bit, and we're going to there's a Python package that kind of does all the work for us already. And we're going to use that to download some data and look at some basic correlation stuff. So let's wait about 30 seconds or something. Let me get my music back going. Got a little jazz today. There's an accompaniment while we wait for some of the stuff to download. So obviously this is NBA.com. First thing we're gonna do, we're gonna go F12, open up our browser console, and we're gonna go right to network. So anytime you make a change to a website, sometimes some of these things are happening while the site's just active. We don't have to do anything, but when we click on, let's say, preview of this Mavericks game tonight, we have all these browser requests that show up, right? All this crap. All this stuff is just hitting different APIs and loading the web page for us, right? Rendering the browser page. But specifically, when we're looking for API requests, what we want to do is look inside of the Fetch XHR tab. And now here's all of our requests that the NBA is making when we load this stuff up. And so let's go ahead and go to let's go to Teams. All I really want to do here is we're gonna do correlations for my team, your Portland Trailblazers, and let me make sure I can see everything correctly. Kind of got a weird setup here today. All right, that's better. So let's clear out our browser requests. Let's go in and find the Blazers. So you can already see here, right? We're hitting stat/team/ and then we have this number, which is the team ID. Seems pretty straightforward, right? And like if we load a different team, this ID would be different. What we want to do is I'm just going to go back to the schedule and load up an old game. And all I'm going to do is I'm going to look to see what requests are happening. Because in order to calculate correlations between players for fantasy points, we got to get the box scores, right? We got to get the box scores so we can calculate the fantasy points for each game and then run the correlations in Pandas. So let's clear out our requests again. And let's just load their most recent game. They lost to the Clippers in the NBA Cup. So now we're loading all this stuff up, and you can see all these requests happening. It's a lot of junk. But what we especially want to do is want to hit on box score. And when we do that, we should find that we've made a request. So let's scroll through some of these. The NBA has changed this up. It used to be a lot easier. Now they've kind of really hidden some of these requests. Let's see. Gen 204, blah, blah, blah. Let's try that again. Let's go back to box score. Should find it in here. Come on. I know there's a request. Maybe it's not a Fetch XHR. Maybe it's just in here. No. It's reloading these JSON ones constantly, which is not quite what we want, right? We want the actual box score. Maybe if we just refresh here, we're on the box score tab. Let's clear out a request and just refresh and see if it pops up, what we're looking for. All sorts of nonsense. Game card feed. No. What happens if we go, excuse me. Here, let's do it this way. Let's actually just make a request in the box score. So this is like the range filter. So if we were to filter out to just Q1, for example, now it'll refilter this, and now it's hitting the API, right? Because it's changing these values. So where did we make that request? It's got to be in here. All right, let's do that. And let's just do Q2 now. Here we go. Okay, we found it, right? Here, so now we made that request. We changed it to just look at quarter 2, and now we can see stats, box score traditional V3, game ID, league ID 00, in period 2, in rage. So this is the time in seconds, right? Or in milliseconds, I mean. So if you were to, is it milliseconds? Yeah, I think it's milliseconds. Anyway, if you were to add up all the times from the zero would be the start of the game, and then 28,800 is always going to be the end of the second quarter. We don't really need it there. We can just use in period. And so if we go back to all periods, so we can clear this out and go back to all periods, and we'll see that same request, but now it'll show the entire game. Maybe it won't. Maybe it's let's do that again. There it is again. Okay. Actually, 28,800 might be the end of the game now that I'm thinking about how they're doing this. Okay, so let's go into Cursor. So we found this request, right? We have this URL. So we can go into screen 2 type. We don't see the full screen. Oh. Okay. Okay. Let me just share the entire window then. How about that? Share screen. What if I just share the entire screen? Screen 2. Now you should be able to see it, right? So again, let's go ahead and we're on our box score. So we're going to start recording our network requests. And we're just going to choose quarter 1. It should pop up. If not, we can just refresh it. In fact, let's just refresh it. This will be. So clear this out. We're gonna go to quarter 2. And I wasn't recording the network event, so we missed it. There we go. So now we see this request to stats, box score additional V3. Here's the game ID. League ID 00 is going to be the NBA. I don't remember which one WNBA is, but there's people have references built up. Then we have the periods here and start period. So from here, so we have this URL. So let's go ahead and just open up. We have this. I made a folder. Oops. So we'll just say, let's go ahead and make a virtual environment. So Python -m then dev. So we're just making a virtual environment in our NBA correlation demo folder. And let's just make a sample box score request.py. So we need to change directory into our venv. Then we need to go into scripts and activate. You need to always do that to activate your Python virtual environments. So we're back. Now we're back to our root folder here in our terminal. And we're going to want to install requests. This is Cursor, by the way, the IDE we're using here for Python. Oh, nice. That'll be helpful. Oops. Let's open this on a different screen, shall we? Let's see what we got here. Oh, very nice. Very nice. Okay, that'll be very helpful. All right. So we've installed requests. We also just want to upgrade pip. Just so we don't get that warning anymore, really. It doesn't matter that much. And then we're also going to install pandas to do our analysis in. So then we're going to do import requests, import pandas as PD. And we'll try to run it, and it's going to throw, we need to install some stuff into here. So it's installing just Jupyter Notebook kernel, so that way we can just run this stuff in line in our IDE. Excuse me. So we should be on our Venv. Looks like we are. Looks good there. We've imported our packages. So let's go back to our request. So we already had this, right? Yep, and cursor's already telling us, okay, let's make this a URL. See, it's already done all the hard work for us. And now if we just run this with the current URL that we used in the network requests, what we're going to see is we're only pulling the third quarter. And actually, before we even do that, we'll first notice that it's not going to work because the NBA has a bunch of headers that you got to use. So if we look back on our request, we see in our request headers here, we see all of these, right? Except encoding. So we can just copy these. We can copy these. And we could do this, right? And now we could just tell, cursor, just convert these. Oh, we want, actually, let's not do Control L. We can do it instead, Control K. Convert these browser headers into a dict for Python request. So now what's going to do is it's going to automatically just fix the stuff for us, make it a lot easier. Here we go. See, it's already filling all the stuff in. And we can go, good job, cursor. And then we need to say, hey, we need to give it these browser headers. So now, like, I believe all you really need are these three, if I remember right, and user agent. But we'll just bring them all in. It should be okay doing it this way. And these requests are just basically authenticating your request with the NBA API. So we can interrupt, and we can rerun this. And actually, I mean, even easier. Let's just do this. Create a whole new. So all the endpoints are publicly available. So you could do it like, right, we already pulled this. It's not too bad. Their API is pretty well documented. It's just there's just basic kind of don't try to scrape like don't try to make too many requests at once. You know, there's just like general things to do so you don't get blocked. And it's kind of, and like even their stats and data update stuff only runs every 3 to 5 seconds. So like when we are going to be doing some looping here in a second to download all the games for the Blazers, we're going to want to be nice and not like just jam them with requests. We're going to kind of slow them down a little bit. But like all their endpoints are publicly available. They're pretty well documented. And there's even a package that we're going to use here in a minute to make our lives a lot easier. I'm just doing this to show you guys how to figure out how an API works, how to scrape it, and how to hit the request. So like we could do this all with browser requests, just like we're doing now. And we could convert this response.json just like this. And the NBA API is so well documented that Cursor already knows how our response is going to work. So, and that just goes to show. So if we do this, oh, maybe not. So let's do response dict equals like that, and then we'll see what the keys look like of our response dictionary. Once I fix the parentheses, I know I'm going kind of fast here. So if we look at the structure of the request we made, right? So we had this meta, which is just giving us all this information, and then we have the actual data, which is within box score traditional, right? These are the two keys, and so we can do response dict. That's not quite what I was looking for. Let's just do response dict box score traditional. We run this. Now here's all of our data. It's a lot of data. So let's do that again, but instead let's just do keys so we can see what's going on. So we have all these keys: game ID, away ID, home team, away team, right? And so like if we were to look at game ID, here's the game ID, right? If we were to look at away team ID, it's probably going to be a single response. Yep. Here's the Blazers team ID that we already found. And if we were to look at away team, I bet we're going to find a bunch of, let's look at, I believe this is going to be a list. We'll see. Nope. So let's see what the keys are within our box score. Now we have all this information, right? Team ID, Team City. So now this is all just the Blazers. So I think if we do starters. So here's the combined stats for the Blazers starters in the third quarter of that game. And right, because our request is actually pulling, we can do in period equals, I think we could actually exclude it completely like this. And now we've just removed the periods completely. Should still work. Now, if we look at this, oh, maybe we do need to provide an end period. Let's say start period equals 0. The reason why I don't want to give them an end period is I'm not sure how they're going to handle overtimes. So let's try this again. No. Well, maybe I do have to provide an end period. Let's say like 9 or something. Here we go. So we did get it for the entire game. Here's the Blazers combined stats for all the starters. Not that useful, right? Because we need the actual individual stats. So let's go to players. And now look at the first player. Here's Jeremy Grant's stats from that game. Was it yesterday or the day before? He played 35 minutes, 5 for 11 from the field. Pretty simple, right? And so now we could write something. We could do, I bet if we just did this, like a away DF, what happens if we just make that a data frame, right? Now, their statistics aren't perfect, so we'd have to figure out a way to do that. But anyway, long story short, that's how we're hitting the NBA API. It's that simple. All we do is we go into our browser requests, figure out what requests we're making and what these, if we look at a payload, we can see what all these mean, right? Figure out all the individual parameters we put in. Then we can adjust the URL as we need it, and we feed it the same headers. And Bob's your uncle, as they say. And also, like, if you look at the actual response in the browser, you know, I could have done this. I could save myself a lot of time by just looking at this. So like now we see that actually the statistics for each player are embedded within the player object. So we, like, the way I converted that to a pandas data frame was imperfect, right? And so like we would actually parse it differently than what I just did, but it's okay. That's beside the point. That's just a general, like, we're going to scrape any API. That's how we're handling it. We go into this website we want to scrape. We go and find the browser request where they're hitting their own internal API, figure out what headers we need to make that possible. And then we're feeding those same headers into our Python request library. And, you know, there's some stuff about using Selenium, for example, if you need to imitate a browser, that's more complicated. There's also like certain things, like, for example, if you're downloading the DraftKings contest standing CSV with Python, you have to feed in a certain token that expires after 2 hours. And so there's just other like little stuff that you might need to do. But this is just like the same general principles you can always apply for any browser API request for any kind of data you're trying to get. But the nice thing is people have already done this work for us. And so instead of having to do that and write write something that'll get this stuff into a nice box score for us, we do some kind of loop to create rows. How do you generate that token? It just happens when you make a browser request. So, for example, here's DraftKings. So if I go into inspect, So we'll go to NFL. We'll just look at a live contest for NFL. Here we go. So let's look at the flea flicker from Monday, Thursday. And here we go. So we'll look at the flea flicker. Active contest. If you don't have Jameis in this contest, you're cooked. And probably Marvin Mims too. And Jerry Jeudy. Basically, if you did a second, like, look at this. Look how crazy the scoring was from that game. You got a 43-point score, a 26-point tight end score, a 40-point quarterback score, and a 20-point the opposing defense got 20. That game was crazy. Jameis, shout out Jameis, legend. So anyway, if we want to download these lineups into a CSV, export lineups to CSV, and now we've made these requests, and now our request has automatically generated this big cookie here. It has all the stuff we need. So we would just copy and paste this and then add that to our headers and when we're making requests to our export full standings URL, and then it would automatically just generate that. But you kind of have to go make a browser request and then imitate it later on. So that way it generates that signed cookie for you. Yeah, that game was crazy. It was fun to watch. I thought Cleveland was going to win too. Obviously, the pick sixes kind of hurt that at the end. Anyway, so we have this NBA API Python package. We can just run this. So let's go ahead and pip install it. So we'll comment this stuff and we'll say just like making a sample API request to NBA.com, right? And we'll ignore that for now. And then we're going to import NBA API as, we'll just say as NBA. So that way we can just reference it that way. And actually, it may not be the best way to do it. Instead, we're going to actually just import the function directly. We have this box score traditional v3. So we can import that. And now we just have a box score. We can type in this function. And now we have a bunch of, gosh, cursor's so good. Just knows. And there we go. So now we've downloaded for this game ID. We can actually download with this endpoint here from the NBA API. So if we look back here at the NBA API on Git, it's nicely documented for us. So we have all these endpoints. We have a scoreboard endpoint, player career stats. What we really want is, we'll go into endpoints here. And we want the box score traditional, but then we want the box score traditional, and we want so we have this marked down here, and we need a list of the game IDs for each team, right? Because game ID is a parameter. Excuse me. So we're going to look for league game log. And there we go. We have all these different parameters we can apply. Super easy. All we really need to give it is league ID. It says required. I'm not sure they're actually required, but we'll see. Actually, maybe it's maybe we need to use team game log. Yeah, let's do team game log. The reason being, we only need these parameters. That other one, we need a lot more. You could use anything. Like the simplest is just write this stuff to a CSV. Because, with pandas, it just turns it into a tabular format anyway. And so you could store it in a date. You can make a little MySQL database, a little SQLite database. The easiest is just, the simplest and easiest is always just save it to a CSV and just access it that way. But anyway, so let's go ahead. And what we're going to do is we're going to hit team game log, and we're going to download the Blazers game logs for the 2024 season. So we're also going to team game log. I believe that's all we need. And down here, so we're going to do download Blazers game log. So, I mean, it's already figured it out for us, right? We're providing a team ID, the season, and this get data frames is this nice little function that the NBA API, this library does, is it automatically converts into a pandas df for us. So we can just do game log. So games df equals that, and then let's just double check and make sure that that's actually the Blazers. So if you remember, we can actually look inside of our preview, and here's our team ID. It's like that. Boom. So now if we run this, here we go. We got a nice data frame. Here's the Blazers data frame for all these games. So we have all these game IDs now. And we can do pd.data frame around our request. Ooh, maybe it's get data frame 0. Let's make sure that this is actually a pandas df. It looks funny on our print. I guess it is. The print just looks funny. Anyway, so here's our df. Team ID and game ID are really all we care about here. We could pull, so this is all box score information, right? So like if we were to do games df PTS points, here's our points scored for every game this season. But we don't really care about that, right? We just want the game IDs. So so we could do this a couple different ways. The easiest is probably just for game ID. So now if we do this loop, right, for game ID and games df game ID, print game ID. And it's not the right column name. So let's just do games df.columns equals games df.columns.string.lower. So now if we look at this again, now our columns are all lowercase, which will help a lot. And now we can just change that to game ID. Cursor already knows what I'm doing. So here's all of our game IDs. Okay, so now we want to make box score requests for each game. And let's also import time, just to show you guys how you should be doing these requests. So what we want to do is, so box score dfs equals like this. So we'll have an empty list. And then for each game ID, we're going to do exactly what this is doing. pd.dataframe. And let's go ahead and also just print so we can see what the box score looks like. We'll do that. So now we're going to go through each game ID. We're going to hit this box score traditional v3 endpoint from the NBA API using that game ID. Then we're going to do the little get data frames function and just pull get data frames would be like if we were to use, I think, the team game logs with the plural endpoint, for example, it would return multiple items in a list. But when we're returning just one box score from one game, it'll only return a one list object. So we could test this. So time.sleep 1 is probably fine. We'll do 3 just to be nice to the servers there in New York. We don't want them to overheat and Adam Silver to get mad at us. Just general nice scraping. So here we go. Here's the first game. You got all these guys. Here's Quentin Grimes. Looking good. Bunch of plus minus. I'm guessing these are the Blazers plus minus with those numbers. That's what it seemed like so far this year. This will take about a minute. It won't be too bad. Is anybody playing the showdown tonight? Yeah, Rip City, Tank City. We're pooper scoopers for Cooper. We're going for it. But actually, they've been. I mean, the the net rating for the Blazers is freaking awful because they've lost some games by like 40, but they've been competitive in a lot of games. They're really competitive twice against the Thunder. They beat Minnesota twice in a row at home. Almost beat Houston twice in a row on the road. So they've been competitive, but yeah, like they are in. If they aren't already in Cooper Flag mode, they are going to be. And who's the kid on Rutgers who's also going to be a really high pick? Ace Bailey. I think he's also would be a nice one for the Blazers. Okay, so are we done here? Is that all? So like a cheap way of making sure that our requests are done and our loop is done without having to scroll all the way to the top because we have all these prints. We can just write print box score df. And if this runs, then we know that our requests are completed. And there we go. So it looks good. Okay, so now what we're going to do is we're going to do final. So we can just say df equals p concat box score ds. So now what PD concat is doing is going to take this entire list of objects and it's just going to stack them on top of each other one by one. If, for example, we wanted to make them lengthwise, so let's say that would be a good example of why you would do this. You have like column, you know that two tables are aligned perfectly and you just need to put the columns together. You would do axis equals 1 and that would append them column wise. But in this case, we're doing axis equals 0. It's going to append them row wise. So now we have look at our df now. And if we were to do df, let's say game ID dot value counts. So here's how many rows there are for each game ID. Looks good to me. If we were to do the same thing, let's say we actually just do df.summarize. No. Let's look at points value counts. Just to show that this is working. Bunch of DNPs here. Yeah, I agree. The lottery does help a little bit, and I think the NBA Cup, at least early in the season, helps as well. But yeah, it's this year might get pretty egregious at the end of the year for some of these teams. The Blazers are definitely like going to be making moves here, trading away Grant and Ayton, I would assume. Just play Klingon all the time. Although Klingon is probably a better player than Ayton right now because he's so good defensively that they may just want to keep Ayton around. It'd be too hard to take with Klingon. So, excuse me, my voice is cracking. I got a cold. So let's go ahead and look at our df.columns. And what I first want to do is well, let's open up let's go ahead and do this. What I'm going to do is I'm going to be lazy, and we have all these columns, and I need to make a DraftKings points column, right? So I'm going to go into Cursor, the AI chat, this Cloud Sonnet chat, and I'm going to give it. I'll show you what I'm doing. This thing will slow down. There we go. So what I'm going to do is go into the NBA Classic A contest for today, and I'm just going to show the AI the rules, the scoring rules, and then just take a screenshot of it, and then it's going to make a function for me to calculate the points. So this is just being lazy. So now I've just copied these scoring rules, and I'm going to say, given this df and columns, can you make a new column that is DKFP, or we can say FP like this. We'll make it camel case because right now everything else is camel case in here with these scoring rules. So now we're just feeding it all this information. I'll hit enter. It's okay. So let's go ahead and just see what happens if we run this. Nice. Okay, so let's say df dkfp, kind of get a gut check here. Looks pretty good to me. We could also, for example, go into view data at the top. You have to give the kernel access. And now, if you view data, the VS Code or in Cursor, because Cursor is built on top of VS Code, it has a data wrangler. It's called like a pretty nice, pretty advanced. Wrong screen. It has a data wrangler here. So it has all these variables that we've already defined, right? And all I want to do is I want to look at our DF. So I'll open that up for us. And let's look at the first row of Jeremy Grant. This is the most recent game. So we had what? 2 threes and 4 rebounds, 4 assists, 2 steals, 2 blocks. That seems about right. 31. I'm just going to pretend like that's right. I don't really care too much about it being accurate. The other cool thing about Data Wrangler is normally to like print these distributions out, you'd have to write some extra functions. But if you just open up the Data Wrangler in VS Code or in Cursor, it actually just gives you the distributions right there. For string columns, it tells you what's in here in our strings. And for these, like here's our field goals made. Now you can see these distributions, right? 0 is pretty heavy. But that's because we have a lot of cases where players didn't play at all. And so like DND, injury illness, did not dress, not with team concussion protocol, DNP coach's decision. And I think it actually would be helpful if, well, okay, there's kind of 2 different ways, right? We could leave in the coach's decision and say that, well, like these players who are coach's decisions, DNPs, actually they're going to score fantasy points in games where the team gets blown out. And so they might be negatively correlated with the starters a little bit, right? Because like normally they get 0 and normally they get 0 and the starters get a bunch of points, but actually in games where the starters don't get very many points, maybe these guys that normally get 0 get fantasy points. So let's go ahead and just leave coach decision in. So now what we're going to do is drop rows where and let's go ahead and say where minutes is blank or 0 and comment is not equal to, so we're going to copy cell. I don't think that's quite what we want here. I think it's actually kind of not doing what we want. So if minutes is blank and comment is not DNP coach's decision, then drop row. So now let's see what happens when we do this. So okay, this looks better. But for simplicity's sake, let's just go ahead and just say, drop row if minutes is blank. So we'll get like we'll change this to be like what's a good I don't know, final DF, we'll say, pretend, or players. We'll just say final DF for now. That way we don't have to change our original DF. We can still do analysis on our original DF if we want. Now if we look at this, so now we should always have rows where players had minutes. So we can also verify that. We go in, look at our final DF, and look at the minutes now. So we even have non-starters, and we have everybody in here played minutes, right? So that's fine for now for what we're doing here. Yeah, if you show cursor, because cursor is just hitting API endpoints for whatever LLM model you're using. So if you're using ChatGPT or Claude, so if you just show it what the data looks like, it generally does a really good job of figuring out what kind of code it needs to write. I've never really, sometimes it's wrong, but you just kind of test it and don't overwrite your variables so that way you don't erase all your data. And that stuff is usually able to figure that stuff out pretty quick. So if we look at so actually one more thing, I only care about the Blazers for our analysis. So we'll say Blazers df equals, it's not quite there. It's not quite there, but we can do team tricode pour. It added a space for us. Now, if we look at our Blazers DF, now we have all the Blazers who played minutes in a game this season. And here's our DraftKings fantasy points in that game. And now we can just do, let's go ahead and let's make a new column. Let's just make a new column. First, let me make sure about the column names, actually. Maybe there is already a full name. What does player slug look like? That's like for their URLs. And it's not last name, it's family name. So now we have full names. Okay. So we have full name and we have DKFP, right? So let's just so now we're just going to put that comment in there. So if we do Blazers, perfect. Okay, so let me explain what this is doing. So let's first just do Blazers df.pivot. And we're going to do full name as the index. So let's run this and see what it looks like. I think actually we want it this way. Perfect. So what we've done with this dot pivot is we've set the index to be game ID. So that way each row corresponds to that Blazers points for that game ID. So like this game here, DeAndre Ayton didn't play, so he gets an NAN. This game here he played, he gets 43.75. This game here, Donovan McClingan didn't play, he gets NAN. So we've indexed on our game ID. And then what we're doing is we're making full name our columns, right? So now here's our names. And then our values are the fantasy points they scored in that game. Okay, so that's what it looks like. And now when we run a correlation on it, there we go. So now we have Anthony Simons. It's correlated perfectly with Anthony Simons, of course. Strongly correlated with DeAndre Ayton. Strongly correlated with Deni Avdija. So these don't surprise me, right? These make sense to me because you would assume that the primary ball handler is correlated with your centers quite a bit. We can also see these look really off. I'm surprised by the Shaedon Sharpe one because Simons and Sharpe start next to each other. And what we do also see is that the bench players are strongly negatively correlated to Simons. So games where the Blazers get blown out, Simons doesn't play well, obviously, right? Games where Duop Reath plays, not a good sign for the Blazers. And same with Jabari Walker. Same with Ryan Rupert. And so that's like the most basic correlation analysis we could do, right? All we did was we filtered out games, basically any games where somebody didn't play. And we got the Blazers, figured out what their names are, like this. So we have these correlations. Oops, got core. And so again, just showing this is what it looks like now. And then, so we can also see like Don McClingan and DeAndre Ayton have negative correlation because they don't play together. Same with Duop Reith and DeAndre Ayton. All that makes sense to me. Now, there's a lot more stuff we could do to clean this up. The way I filtered this down right here, it may not make a lot of sense to do it that way. You may actually want to, like I was trying to do earlier, you may want to keep the DMP coaches' decisions because those you can just set those to be zeros. And in fact, that might be the better approach. Like if we were to do final DF minutes equals np.where import numpy is empty. So we can do this np.where, and we can say if final DF comment equals, then set minutes to like this, right? Oops. So all we're doing is making it so we're making it so now if we're looking at df.minutes, we'd have some more zeros in here. And now when we filter and run this stuff again, these numbers should change a little bit for some of these players that don't play. So now we have like Bryce McGowan's is in here. He's on the bench. He hasn't played in a single game, but he gets all coaches' decisions. We get a little more negative correlation here. So this stuff, that was a fine approach. But what we can do now is we can actually convert these. If you're using our GitHub repos, which are free, by the way, and you can use them to do use our optimizer and use our simulations, and you can put in your own correlations. What you can do is exactly what this looks like. So you see how this is formatted like a dictionary, right? So we can do this. We can say, let's go back into our AI chat here. We'll show it these and say, I want our Blazers core DF to be turned into JSON dicks like this. And actually, I believe instead of having a separate row for each one, I think we could just do, for example, concat these down to one. I don't think it makes a difference. For the sake of this example, we can get the dog to not bark. And we can just have the AI do this for us. It should be pretty good at this. So we'll try this code it just gave us. And now it's creating a Cordic, and it's going through our index and our columns here and trying to figure out don't like have Anthony Simons is perfectly correlated to Anthony Simons. And we'll also do one more thing here. If so we'll say skip if NaN. Just like that. There we go. And now we have these all formatted for us. So we could take all these correlations and dump them into, I don't have it up, but we have our repo. You have in our config.json, you can put all these in. Now we might have to do a little bit of formatting here to make sure these work correctly. I think these might need to be strings, for example. But these are pretty much like 99% of the way there now to where we could just paste these in to our GitHub repo. Let me pull that up actually so I can show you what I mean. Inside of NBA DFS, damn it, NBA DFS tools. Here's the URL up here. So if we go into our sample.config.json in here, we have these custom correlations, and you can see how these are set up. So you can set it up by position. Obviously, for the NBA, positional correlation, by default, we're using positional correlation in the repo and on the site, but it's very slight. It's mostly to not allow like lineups where you get, a good example for the Blazers would be lineups with DeAndre Ayton and Robert Williams III, for example, because they're just straight 1-for-1 players. We also do it for starters. We have a slight positive correlations in the games, but like they're very, very small, and you can see them on the site if you click in. You can also see them in the code in our repo. But anyway, so you can see how this is formatted here. Custom correlation is Trae Young, blah, 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 Damian Lillard to Giannis. Positive correlation here is an example. And so now if we look at our output here, we're like 99% of the way there, right? Ryan Rupert with this correlation to Jabari Walker. Now, what I would say is, especially with our simulations, these are extremely strong. Like to Justin Minaya, for example, that's extremely strong. You don't want to be, the way that we are generating the player fantasy point samples, you don't want to be too extreme with these correlation values because you can get strange results. For like a player, it depends on the distribution that you're sampling from, but you can get some pretty extreme results where you can get like in games where, let's say you had a game who's it? Oh, like Jeremy Grant, Dwap Reith simulates really well. Then Jabari Walker might have some outlier performances in the sims that you might not want. So I'd say you probably want to do some little cleaning on some of this data on these correlations to make them a little lighter. But this is a pretty good start. This is getting us like 99% of the way there. This is just doing the Blazers, obviously, but you could pretty easily, and I believe on the NBA API package, there is a static, let's see, in here, they have a static data set that has all the team IDs. See, if we were to pull this, we could do teams.getTeams, for example. So here's a list of all the teams. Here's all the team IDs. So if you wanted to get all the correlations, you just write a simple loop. You loop through, and up here, when we made our request to our team game log, we just changed the team ID. We could also loop through seasons. All this stuff is just pretty simple looping, right? And you just need to be kind to the servers and not overload them with requests. Just time.sleep them, and you're good to go. So anyway, I think that's about it. Take about an hour, so I don't really want to go too much more than that. Like I said, there's a lot more work that could be done on the correlation side here to kind of fine-tune these values so that you don't get some extreme values in here on the correlation side, especially for the NBA. One thing that you might consider, for example, is doing I think one good way to approach this is if you cluster players, instead of clustering by position, because the NBA is mostly positionless, you could cluster players based on their season-long stats. And then, so for example, Anthony Simons might cluster in well with other volume shooters like Jordan Clarkson, Darius Garland, maybe, although he gets more assists. And so you might cluster players that way. So you find similar players on different teams. And so like that way you can compare let's say Anthony Simons and DeAndre Ayton, right? So you might say Anthony Simons fits in with like a volume shooter cluster. DeAndre Ayton fits in with like a traditional big cluster. And you might find those similar correlations between, for example, in Cleveland, like I was going with, you would say like, okay, well, that's pretty similar to Darius Garland and Jared Allen, for example. And then you could say, well, Anthony Simons and DeAndre Ayton have this like 0.45 or whatever correlation, but Darius Garland and Jared Allen have like a 0.2. And so you might end up taking the average of those values. Actually, they have a 0.67. So that's really extreme. So you might want to do like I was just saying, like, let's say that for Cleveland, that sample correlation was 0.2. Well, then you just find the average. You end up with a 0.4, which is much less extreme. And you could do that for every team, and you can kind of figure out the relationships between players in clusters instead of just individual players. We're dealing with smaller samples, and you can get some pretty extreme values dealing with smaller samples. So that's a simple way to approach it. That's probably the way I would approach it. I thought about doing that on the site side, doing something like that, but I haven't really dug into that too far. I'm pretty happy with how the NBA player results simulate. I don't really see the need to do that, but maybe there is a need for that. Maybe we'll have to explore that. So anyway, any last kind of questions here before I jump off? I know it was kind of quick, but I didn't do much like on the actual data analysis side, but I just wanted to show how we do. It's more important for people to understand how you actually get data to be able to do your own analysis and figure this stuff out. And you could always ask, we could go into chat right here and say, hey, here's the problem I'm trying to solve. I want to get these correlations, but like this correlation seems pretty extreme for the NBA because the NBA is kind of almost a zero-sum game between players on the same team in a way. Obviously, you can get assists, but it's not like football, for example, where you'd have really strong positive correlation between a quarterback and receivers. It's a little different. And so you could always just go in and ask an AI how they would approach it. And they probably give you some pretty good suggestions as well. So, but it's more important, I think, just to show people how to scrape a site, scrape an API, get that data down. Once you have the data down, there's a lot of stuff you can do with it. And then at the end, we could always just save, we could save our correlations here to a text file. We could just save the entire Blazers core.csv, .2, and we would just write it to a CSV. And if we look at our files now, we have this CSV file that we can just pull up, and we have all the correlations already preloaded, right? So pretty simple, pretty easy today. Not going 2 hours like the last couple of times. But hopefully you guys found this useful. And don't forget, like and subscribe. It really helps us out a lot when you guys do that. And if you have any other questions or any other topics for code-alongs that you'd like to see us cover, we'd be more than happy to do that. We've had a lot of success, I think, with people kind of checking our stuff out from all these code-along stuff, just seeing how you can do Python. So, yep, no problem. Thanks for watching. Yeah, good luck tonight. I don't know what I'm going to do. It's good. It's going to be a good game, but I don't really know. I know everybody wants to play Dontavion Wicks, but I don't know. I do like the Packers side of the game. I'll say that. Lions have been kind of, I don't know, maybe this is the game where they kind of get up for it, but they've been kind of coasting here the last few weeks. So I like the Packers side, but we'll see. So anyway, thanks for watching. Thanks for tuning in, and good luck tonight.